Okay, so we're gonna start learning the laws of exponents, which are basically like your order of operations for problems that have exponents in them. And there's about maybe 7 rules that we've got to learn, so we're gonna learn the first 2, the product rule and the quotient rule. Now, just a little reminder that the big number is called the base, and the little number is called the exponent. 5 squared means 5 times 5, which is 25. It does not mean 5 times 2, which is 10. Okay, that's like one careless mistake students make all the time. That little 2 tells you how many times to write the 5, and then you multiply them. Okay, so let's go ahead and get started. Let's start with the product rule. We know product has to do with multiplication. On your math chart, this is what you're going to see. And a lot of students look at that and they're like, well, I don't know what it means because it's all letters. Well, here's what it's saying. That if you have the same big number, that if you're multiplying the same big number, you leave it alone. And all you do is you add m plus n. You add your little ones. So that's exactly what the product rule states. If you multiply 2 numbers with the same base, just add the little ones. For example, my base here is 5 and 5. So then, since the bases are the same, I leave it alone. And then all I gotta do is add my little ones. So what's 2 plus 6? 8. And then that's the answer. Here, my bases, even though you can't see them, they're all the same because they're imaginary ones. So you leave them alone, you write down the y, and then you just add the little ones. Now, the little numbers, I have a 4, a 3, and actually I have a 1 here that they don't like to write down. You cannot forget about that one. So 4 plus 3 is 7, plus 1 is 8. Okay? Now, what happens if your bases were different? Well, bases meaning the big numbers, okay? If your bases are different, you must, that's why it's called a product rule, you must multiply, this is why it's called a product rule, the bases, so multiply the big numbers and add the exponents. For example, if I gave you the same problem, but I add a variable to it, like for example, if I put 5x squared times 5x to the 6, well, that changes everything. A lot of students might want to be like, oh, well, the bases are the same. Well, no. You see how that little 2 was next to the 5, so that's why we kept it the same here. Since we have variables, we got to follow this rule. Multiply your big numbers, so 5 times 5 is 25, and add, put the x, and add your little ones, 8. So there's the answer there. Let's do another one. Identify your bases. They're different, so multiply them. What's 7 times 6? 42. Write down your letter and add 5 plus imaginary 1, 6. Here, identify your bases, -3 and 5. -3 times 5 is -15. And here I have 2 different types of letters, so you got to keep it consistent. X's with X's, Y's with Y's. So for the X, I have a 2 plus an imaginary 1. That equals 3. And then for the Y's, write down your Y, and then I have a 7 plus a 6, which is 13. And there it is. So again, the product rule says, if the bases are different, you must multiply them and add the exponents. Okay, now let's move on to the quotient rule. Now, quotient is fancy for the answer to a division problem. So we know that there's going to be some division involved here, okay? So put a little division sign up here. Here's what you see on your math chart. When you divide the same number, that's why you see A's. When you're dividing the same number, leave it alone and all you gotta do is write down the top exponent and subtract the bottom. So always in that order. Top one first, then the minus, then the bottom. So if dividing the numbers with the same base, just subtract the little ones. For example here, the bases are 1. So we leave it alone. 1 divided by 1 is just 1. Write down your y and subtract. 6 minus imaginary 1. What's 6 minus 1? Well, that is 5. Let's do it again. Here, bases are the same. There's no variables, so then I'm just going to leave my 6 alone. When the bases are the same and there's no variables, you just leave it alone. If there had been a variable, I would have had to have done 6 divided by 6, 1. But there's no letters, so leave it alone. And then just do 13 minus 2. And that's 11. All right. Now, one note that I want you to keep in mind, I started with a fraction, but I don't have a fraction anymore. So question is, am I ever going to continue with a fraction? And the answer is yes. So let me give you an example of that. So let's say I write 5 to the 6th power over 5 to the 11th power. The bases are the same, and there's no variables, so leave it alone. And then I'm going to end up doing 6 minus the 11. Well, guess what? 6 minus 11, that's a negative 5. And there's another rule in the laws of exponents called the negative exponent rule, which states that negative exponents are unhappy where they're at. Okay, so you gotta move them to the opposite side of the fraction. So for example, remember, any number can be made a fraction by simply putting a 1, right? So this guy is unhappy being on the top. So what would make him happy? Moving to the bottom. So my final answer would be this, 1 over 5 to the 5th power. And there's no more negative sign. He's happy now. He was unhappy. I moved him, so now he's happy. Okay, so keep that in mind. We'll do more in a little bit. Look at this example. I see a dot, which means I know I've got a product rule, and then I see the fraction bar, which means I got the quotient rule. So I got both rules in one. Which one do I have to do first? Well, I got to clean up my numerator. I got to do the top. So I got to do the product. So let me go back and read what the product rule says. You must multiply the bases at the exponents. Okay, so then I must take 5 times 2. Well, that's 10. And then I add my ends. 1 plus 4 is 5. And I still have my denominator. Now, what does my quotient rule say? That if my bases were the same, I leave them the same and I subtract, right? Well, my bases are different. Okay, so over here when they were different, I multiplied them because it was called the product rule. So guess what? If the bases are different, I'm gonna divide. So 10 divided by 4, I can't get a nice little number. So sometimes you can just simplify. So 10 over 4 can be simplified by 2's. So I'm going to get 5 halves. Then I write my end, and I have to subtract my exponents. So 5 minus 5. So 5 over 2, and then 5 minus 5, well, that's 0. Which takes me to another laws of exponent rule, the zero exponent rule. Anything raised to the 0 power is 1. It could be a letter raised to the 0, it could be 1 raised to the 0, it could be 10 raised to the 0, it could be a million raised to the 0. Anything raised to the 0 power is just 1. So now what's 5 halves times 1? Well, it's just 5 halves. There's no more ends. All of it was a 1. So let's write the rule. What happened when our bases in a quotient were different? We had to divide or simplify the bases and subtract the exponents. Okay, so let's keep practicing. So I'm going to go here. Here are my bases. I can't divide them and get a nice little number, so I'm just going to simplify them by 5. I'm going to get 2/3. And then I see the first letter is an A. So I'm going to write down an A right in the center. And I'm going to do 7 minus 5 for that one. And then the next letter is a B, and I'm going to do 9 minus 9. I'm going to keep writing my 2/3. Now 7 minus 5, well, that's a 2. And 9 minus 9, that's 0. So what did we learn right now? That anything raised to the 0 is just 1. So 2/3 a squared times 1 is just all of that. So 2/3 a squared, or it can be written like this. Same thing. Okay, that one in the center right there can be put on the top. Okay, let's go to another one. Here, your bases are different, and it's a quotient, so I'm going to divide them. 18 divided by 2, 9. P, I'm going to do 5 minus 7. Always put the top number first, then the minus, then the bottom. And then Q, it's 2 minus the imaginary 1. I'm going to bring down my 9. Now 5 minus 7, that's a negative 2. And 2 minus 1, well, that's just the 1. I don't have to put the 1. What did we say about negative exponents? That they're unhappy where they're at. So I'm going to move them to the other side of the fraction. So my final answer, the 9 and the Q can stay on top. This guy will be happier at the bottom. Now somebody asked, is there going to be ever a time where you have a negative exponent and instead of putting it at the top, instead of putting it at the bottom, you'll put it at the top? Yeah, it could happen, and I'll show you an example in a little bit. Let's write down some notes here. Watch out for negative exponents. So put it right here. Negative exponents are unhappy where they are. Move them to the opposite side of the fraction and drop the negative. So once you move them, there's no more negative. And how about for 0 exponents? Well, anything raised to the 0 power is 1. My paper's moving, so let me write this down really fast. There it is. So excuse my handwriting. Anything raised to the 0 power is 1. Okay, so let's go ahead and glue this down into your spiral, or keep it open in case you need to be looking at the rules so that we can practice, okay? So this page has a front and a back. You'll do all the evens, front and back evens in class, and then your odds will be for homework, okay? So these are your homework, front and back, and these are the class. Okay, so I'll do a few, and then I'm gonna have you do the rest. So I'll start with number 6. What rule is here? I see parentheses, so I know that this is the product rule.